Dear children, today I am going to explain a stack with recursive functions. First of all, see this program in which there are few statements in the main method. Along with there is a function void display, and every statement in this program has got a unique address which I have written beside that statement in comments. For example, the first statement's address is A001 and then A002 is the address of the second statement likewise. In a similar way, you can see that there is a unique address associated with the statements which has been placed within this block of the display function. So with this program, what happens? The nature of the execution or the nature of the control within any program is to flow sequentially. And as we know that the execution starts from the main method and it ends within the main method. So here the execution will start from the very first method and then it will proceed from top to bottom, and in between what happens in between this function call statement will get executed. So what will happen? Control will immediately jump at this function body and it will execute its function body and then it return back to this statement and then it will execute the fourth and the fifth statement of this program. So what is how it executes actually? So in this execution, during the function call, stack is used. So what is a stack? Stack is nothing but it is a data structure which follows the principle first in last out, or we can say that it follows the principle LIFO, which is last in first out. So there are two operations associated with the stack. One is push operation and another is pop operation. So initially in this image you can see that first element enters which is 1 and then second element enters which is 3. So this is whenever any insertion takes place, it is basically push operation which is associated, and whenever we are going to implement pop means that we are going to remove that element from the stack. So since it follows the principle LIFO means last in first out, so first of all whenever we are going to implement pop, so first time 3 will get removed and then 1 will get removed. During the execution of the program, there are few registers and system stack is involved, and one of the register within the CPU is a program counter. So what a program counter does, basically a program counter is a register in the computer processor that contains the address of the instruction to be executed at the current time, and as each instruction gets fetched the program counter increases its stored value by 1. Along with this, there is a system stack which is involved. So during the function call, the address of the statement being executed will get stored in the system stack. The control, then only the control jumps to the function body, and when the execution of the function is over, then the value from the top of the stack replaces the value of the program counter, and after that address of the next instruction is calculated and then next instruction is executed. You just see this code one more time, you will see that you can see that the address of the very first statement is A001. So very first time this statement will get executed and then this program counter will get incremented by 1. So after that what happens, this A00 becomes A002. Then it means next instruction is being next instruction will be this one, and again program counter gets incremented by 1 means the next instruction is this A003. It means at present we are executing this A003. The address of the next instruction is 8004, but it is a function call statement. Until now, the stack was empty. So what is the nature of the control when function call statement appears? The nature of the control is just to immediately jump on the function body, and it simply means it will execute this function body. So what will happen before going to the function body? This stack will receive the address of the current instruction which is being executed, and after that the stack will get this program counter will get modified with this address which is B001, because within the function body you can see that the address of the first instruction within the function body is B001. And after that what happens, this program counter gets incremented by 1, then it becomes B002. Then this statement is executed, and after this statement has got executed, what happens, the control comes back to the main method, come back to the calling code, and since it was a place where from where it jumped to the function body, so further execution will take place from this point only. So from where the program counter will get the address, so it is a stack. So from the top of the stack the program counter gets the value which is 8004, and after that this is stack this stack becomes empty again, and the next instruction which gets executed, the next instruction is now A005. Now this instruction will get executed, and after that next address in the program counter becomes 8006. Since it is the last statement in the main method, and after executing this statement what happens, the program is over. So this is what basic working during the execution of the program. Now I would like to demonstrate you with the help of this how stacks are involved. So in this question children, what we are going to do, we are just going to print the elements natural and natural numbers in ascending order. So here I have declared one variable n, and here this is a scanner class which is for user input. Now ss dot next int. So here enter the limit. Now here after this I would like to, first of all we need to create the object of the class. So here object of the class has been created, and obj dot print passing n. Now see that what happens, suppose the limit is 5, you can see that the values are from 5 to 1. First 5 natural numbers are being printed on the screen in reverse order. So here what happens when control jumps here, what happens, the address of this instruction will get stored in the stack, and after that this function body is executed, and when it returns back the address from the stack will get stored in the program counter, and after that execution is over. So during the execution of this function body, what happens, if the function call statement is before this system.out.println statement, print statement, so what happens, since it is a recursive function and every function call definitely will have the priority over this statement, so it simply means when I am passing 5 here, suppose the limit is 5, and when it function call happens here, so it becomes immediately it becomes 4, but this statement the control has not reached this statement yet. So what will happen, the value of that n will get stored in a stack having this value, or we can say that whole statement will get stored in the stack, and after that when this function receives 4, then again function call happens, then it becomes 3. So here it becomes so during this what happens, before the control is going to call the function again, another value will get stored at the top of the stack, which is 4, and then only its value becomes 3. So in a similar way, what happens, the values in the stack will get stored like this. So first here 3, and then uh, 2, and then it is 1, it is 1. Till now the condition, this base case is not true. So what will happen when we have stored 1, and when here 0, when 0 we are passing, and when this n receives a 0 here, what happens is base case becomes true, and this return statement will get executed. From the function body, whenever the return statement is being executed, control never goes to the main method directly. Rather than it will go to the system stack and checks whether the stack is empty or not. And if the stack is empty, then it goes to the function call statement. But if it is not empty, then it will pop out all the statements which are being stored within the body of the stack from top to bottom. In this manner, every statement will be fetched and executed. So this is what the working of the stack. Now see that what happens with this here, children. When I'm passing this 5, you see that the natural numbers are on the screen, but they are in increasing order. So I hope you have understood the concept of the stack. Children, here a stack is created just because before this statement, this function call statement is there. So and function call statement before this one definitely will have the priority to execute first. So what will happen, with every function call, some expression, one expression will get stored at the in the stack, and after, when this base case is true, the control comes to the stack, checking if it is empty or not. If it is not empty, then all the statements which are stored in the stack from top to bottom will get executed, and after that it goes to the function call statement. So this is the normal working of the stack with the recursive functions. I hope you have enjoyed this video. Thanks for watching.